Thanks everyone for staying on for this very fascinating webinar. Firstly, I should declare I don't have a declaration slide, so I'll just say that currently I'm funded by the Australian Research Council to undertake research on methods for evidence synthesis. And I was a co-author of, I think, 4 of the chapters in the latest edition of the handbook and an associate scientific editor of the handbook. So I'm very pro handbook. After this discussion so far, I hope that this concept of PICO for synthesis that Sue Brennan introduced is now stamped firmly in your mind. And I was prompted by Joe to include the framework when starting off with this example that I want to go through, which is for developing a PICO for a particular meta-analysis in a review. And so let's just say that my PICO for synthesis question was, is psychotherapy more effective than antidepressants at reducing symptoms of depression? Where my PICO is, I'm happy to include in my meta-analysis any people with depressive symptoms, any type of psychotherapy, any type of antidepressant, and my outcome is depression scores. And so I do my systematic search and identify this particular trial, which is a 4-arm randomized trial. And the PICO for this study is that it included people with HIV and depressive symptoms. It actually included 3 types of psychotherapy, so interpersonal therapy, cognitive behavioral therapy, and supportive therapy, and included 1 antidepressant, and it had scores for depression. And so I was like, great, this particular study definitely fits into my, fits the inclusion criteria for my meta-analysis. And so I'll have a look at what results it has available. Then I come across a table that looks like this. Now, this is a table in this particular trial, which includes data for 2 measurement scales for depression, both of which have data reported at 2 weeks, week 8 and 16. And there are my 3 intervention groups, each of which could be compared to the antidepressants. And then they've also provided data on 2 analysis samples, the intention to treat sample and the completer sample. So I have quite a lot of data in here. How much data, you might be wondering, that's potentially eligible for my meta-analysis of depression? There's actually more than 24 effect estimates. And so I say more than because that's the 24 just comes from extracting the data from this table and entering it into RevMan. Technically, I could do several combinations of, say, 2 or 3 of the the psychotherapy groups and compare that to the antidepressant group. So clearly there's a lot of data here. And I just want to acknowledge that I noticed in James' presentation, he used several pieces of the great art in Western civilization to illustrate his slide. And clearly that's what I've done with this particular slide here too. Now, some of you might be wondering, how often am I going to come across multiplicity in the studies I include in my review? And so these are 3 studies that I'm aware of that have looked at how common multiplicity occurs in studies. And on average, we'd say that about 2/3 of the trials you include in your review may have some type of multiplicity results from outcome, be it multiple measurement scales for that outcome, multiple time points, analyses, or groups. And so why is this a problem and why does it even matter? Well, if you have a multiplicity of results for a particular outcome in the included studies, this can potentially lead to selective inclusion of results by the review authors, whereby the systematic reviewer's choice about which result to include are influenced by the p-value, magnitude, or direction of the results. So in other words, it could lead to the authors cherry-picking data to extract from the study to include in their meta-analysis to maximize the chance of producing a meta-analysis that has a result that confirms their prior hypothesis. Multiplicity can also lead to inconsistencies between reviewers in the data collection, particularly if you maybe don't use a data collection form that has a lot of guidance on which particular results to extract. You might end up with quite a mess of data between the 2 reviewers who are looking at the same study. So a recent paper led by Jose Lopez is a really nice introduction and summary of the issues for how review authors could deal with this issue of effect size multiplicity in systematic reviews and meta-analyses. And we came up with a broad framework of two meta-analytic approaches for dealing with this multiplicity: a reductionist approach, which guides you to include only a single effect estimate per study, or an integrative approach, which allows you to include multiple effect estimates per study. I'm only going to focus on the reductionist approach for now, but I think the paper deals probably with half and half devoted to each of these methods, and the handbook does cover them too. But in terms of a reduction approach, one way to deal with when you've got multiple multiplicity in the studies is to predefine some hierarchical selection rules to help guide your data extraction. And so these are predefined strategies to help select one effect estimate from a study when multiple estimates that are compatible with the meta-analysis are available. And it's appropriate to use such selection rules when the multiple effect estimates are available or regarded as being loosely equivalent at measuring that particular outcome, domain, or construct, but not completely interchangeable. If you thought they were completely interchangeable, then you could technically just randomly select one of those measures. But in some cases, you might feel that some of the measures may be better at estimating that outcome domain than others. And so when creating these selection rules, it's helpful to base them on some clinical or methodological rationale. So, for example, plan to select measurement scales that have the best measurement properties, or time points that are deemed the most clinically relevant to patients. Now, not all selection rules are created equal. I managed to come across a couple of selection rules which I definitely admire the transparency, but I'm pretty appalled by the nature of the rule itself. So, for example, in this particular, the top example, the authors have been very honest with us in claiming that diet and food intake data, where the results were statistically significant, were extracted for the review. Or in the second example, the authors have once again stated that we only really focused on the statistically significant risk factors to include in our review. That is, well, yes, it is a selection rule, but it's a selection rule that does lead to selective inclusion of results, and it could bias your review. There's no good reason why they should have only focused on the statistically significant results. So please don't do that. An alternative and examples of some acceptable selection rules come from one of a review I've done with the musculoskeletal group. And so we were interested in doing a meta-analysis of function scores for people with shoulder pain. And we specified that where trialists reported outcome data for more than one function scale, we extracted data on the scale that was highest on this a priori defined list. And then we had a list or hierarchical list of measurement instruments for function, where we prioritized those studies that had the data for the shoulder pain and disability index over the Croft disability questionnaire, if, say, both of those measurement instruments were available in the paper. And we did that based on the measurement properties for that particular scale. There's a lot of work going on at the moment developing core outcome sets, and that's been extended to development of core outcome measurement sets, which is providing guidance and consensus around what are the best measurement instruments that people should be focusing on to measure in their trials and collecting their reviews. So if you have some guidance available already from core outcome measurement sets, then I would advise you to follow that when coming up with these selection rules. We also had 4 outcome time point categories, so very short-term, medium-term, long-term. And within those categories, we said that if, say, data were available in multiple time points within each of the periods, for example, at 4, 5, and 6 weeks in our very short-term period, we'd only extract data at the latest possible time point. Again, the rationale for that was that we considered that to be the most clinically important time point. Now, the Cochrane Handbook does include quite a lot of guidance on this issue of selection rules and handling multiplicity of results. 2 chapters, chapters 3 and 9, co-led by Joe McKenzie and Sue Brennan. As an example, in chapter 3, there is Sue earlier presented a table and a framework for grouping interventions. There's an equivalent table on how to group outcomes and define acceptable outcome measurements and time points for the review. And then at step 5, really handy guidance on how to specify how multiplicity of outcomes will be handled if it's experienced when you come across studies in your review. And then in the chapter 9 on preparing for synthesis, there's another helpful table, 9.3, which goes through not only decision rules based on some hierarchy of measurement instruments based on some clinical rationale, but also some other selection methods that authors may consider using, such as randomly selecting a particular result that's compatible with an outcome, or averaging, or selecting the median effect. So there's a bit more guidance in the handbook available that you might want to consult when embarking on this issue of selecting or developing selection rules for your meta-analysis. I myself and several others are a big proponent of doing this at the protocol stage, as we think that this can help reduce risk of bias in your meta-analyses. It can also lead to a lot of time saved, in that once you have developed a selection rule with good rationale, then there really is no need for you to extract all the results available for a study. As another maybe extreme example, I was looking at a review of a particular observational study looking at risk factors, nutritional risk factors, and I came across or counted there were 60 odds ratios I could have extracted from that particular study. I don't really want to extract 60 of them, and so I think it would make sense that if I had given a bit more thought in advance as to coming up with some rules and guidelines for which data I will select when coming up with these somewhat monstrous papers, and also could lead to less time needed to sort the data for synthesis. As with all of the issues we've discussed so far, it's possible that you might need to revise your plans if the rules you pre-specified aren't really suited to any bit of the data you observe. So it may be that you come up with a hierarchy of measurement instruments, and yet all the studies you find use completely other measurement instruments. But when you do revise those plans, please ensure that those post hoc rules do not lead to you systematically selecting estimates based on their magnitude or p-value or direction of effect. Have some good rationale for making the selection. And that's all I will say. So thank you.